Hi, folks. Welcome to Jamstack at Scale. I am Ishan Anand. You can reach me on Twitter at IANAND. And what we're going to cover today are lessons learned from using Jamstack and headless commerce for really large sites. That sites with, more than 1,000 pages, sometimes 10,000, 100,000. We've even had folks on our platform going over 1 million. Frequent updates or lots of transactional volume, and very often on what you might consider legacy e-commerce platforms like Magento, Salesforce Commerce Cloud, Oracle, and the like. So the common challenges, a lot of our customers encounter when they're trying to make Jamstack work at scale are up here on this slide. For the purposes of this talk, I'm really going to focus just on the stuff at the left. Happy to talk about the stuff at the right during the questions and Q&A, but the most common and most critical challenges are build friction. By that I mean really long build times or frequent build times, A/B testing and personalization, and site speed and performance. So who am I? Who are we? I'm CTO at MoveWeb. We are a platform, and our jam is bringing the Jamstack to large, complex e-commerce sites. Folks like these guys that have 50,000 to 200,000, sometimes even over 1 million pages. And they're using frameworks that you probably know already, Next, Nuxt, and maybe some you're not familiar with that are more e-commerce focused. Frameworks like Vue Storefront or React Storefront or Spartacus, for example, which is a headless e-commerce framework for the SAP Commerce Cloud platform. And we're also core contributors to React Storefront. That's a PWA framework for e-commerce built on top of Next.js and Material UI. Adds a couple e-commerce goodies in, and it's about 2 years old and already proven itself with over $1 billion in annualized revenue. So let's talk about build friction. So we commonly think about Jamstack as having high traffic scalability built in, and it can handle traffic at scale very easily. But when you're dealing with a site that has large number of pages or frequent changes, there's a new scaling challenge with Jamstack, and that's the build time friction as those updates occur or you've got large numbers of pages. And it's really important to understand that scale is a really big problem for larger sites. So here I've got some data on e-commerce here on the left. REVOLVE, one of our customers, has 40,000 SKUs, and here I'm using the number of products as a proxy for site complexity and number of pages. You look at, say, an average retail grocery store in the US, there's about 60,000 products. When you look at the typical Jamstack site, it's usually less than 1,000 and usually less than 10,000, in fact. Here, none of that would even fill to cover a typical physical grocery store, let alone an online one like Staples, which is 200,000 products. If you think about going over 1 million pages, a lot of people think, oh, that's the Amazons and only the big guys. But it actually does happen. So here, for example, TruePar is a B2B forklift parts, very focused niche, over 1 million products. Now think about content and publishing. On that size, again, I'm using the top end of the market. Folks like BuzzFeed, New York Times, over 80,000 stories per year, let alone their entire archive. Washington Post is actually twice that rate. And then you layer onto this the need to do A/B testing, personalization, or frequent updates. So if you're in the content space, maybe that's breaking news. If you're in e-commerce, that's people iterating on what categories things are on, iterating on the copy, things like that, multiple times a day. And suddenly, the build time can become a serious source of friction. So it's really important. How do we Jamstack these sites? How do we bring those benefits to sites that are actually financially powering a big part of the internet? So there's a couple solutions. I break them into the static solutions and the dynamic-ish solutions. So the first one is to optimize your build times. Just make those builds faster. And usually the low-hanging fruit here is saving the build artifacts and only regenerating what's changed. Another technique is parallel builds. splitting that build across multiple processes or threads. And you can't always do this. It really depends on the framework you're using and your cloud provider. But it can be really helpful for some focused tasks, like image processing. And Netlify has a Gatsby parallel runner that's a great example of this. Another option is looking into alternative static site generators. The static site generators that are built in native code, those Go and C++, actually report a lot better and amazing build times. We'll talk about those in the next slide. But one of the caveats here is that framework and cloud provider support for these types of build times really varies. And some folks make it really easy, say for example in Gatsby Cloud, but if you're trying to roll it yourself, you might find it harder to do. There's another key issue, which is if you're dealing with a site with large pages, say 1 million pages or 100,000 pages, the traffic distribution to those pages is not even. In fact, it's probably following a power law. So if you've got a large number of pages and there's a large number of those pages that have infrequent, uneven distribution, and you're rebuilding those pages multiple times a day for the entire site, there's actually potential excess cost. You're actually rebuilding a large number of pages that nobody has yet visited yet, and then you're going to rebuild it again multiple times a day. And that's not just harmless when you're dealing with a large number of pages. It's actually additional CPU cost you might be paying in build time just for sites that aren't being visited. So I mentioned native static site generators. Hugo is probably the most well-known and most mature, famously used by Smashing Magazine. Here's a couple benchmarks around 10,000 page. Here Hugo's reporting just a couple seconds. NIFT is also very fast. Toast, which is built in Rust, is a newcomer. Also still, under about a minute. And there's a lot of potential there. It's a new emerging framework I'd recommend, or static site generator I'd recommend you take a look at. Client-side rendering is another technique. You might know this under the name of an app shell or a single page application fallback, or SPA fallback for short. And in this model, what you do is you basically decide not to build everything at build time. You just build a universal page, which is really just an app shell. And then, when a request comes in for, say, product ID 2, or whether it's product ID 1 or product ID 1,000,000, your Edge or CDN routes all those requests to the same identical page, which loads up. It's got an app shell with a client-side router and placeholder content. And then when that page is running in the browser, JavaScript on the page figures out, oh, I am product ID 2, makes the API request for product IP 2, and displays that content on the page. And this is really efficient because you only really need to change one file at build time when you're iterating or changing content. The problems with this is it may negatively impact your performance. So obviously, you now need to wait for your JavaScript to run, your JavaScript to fetch API data, and then put it onto the page before the user can see the content. Another issue is it may negatively impact your SEO because some bots can't read that JavaScript content and won't actually even execute JavaScript. Now, Google, says the new version of their crawler can, but some social media platform bots cannot, and so it may negatively impact your organic traffic. And then finally, it requires some CDN provider support to map all those URLs down to that single page. Often you'll do it, where the CDN doesn't have a lot of sophistication through a 404 fallback for anything that doesn't match, known routes. Thankfully, this is made really easy in the Jamstack platforms. I've got 3 examples here. Netlify has a redirects file, Vercel has the vercel.json, and then we have a system we call CDN as JavaScript that makes it really easy to specify an app shell. A newer technique is incremental static generation. And I personally see some precursors in this across the web, including Phil Hawksworth had a really interesting CSS tricks article back in 2019 where he demonstrated a site that kind of incrementally got rebuilt, generated these virtual lollipops as users entered data, even though it was entirely a static site. And then in 2020, Next.js came out with incremental static generation, and they demonstrated it famously using tweets, which I've shown screenshots of here, where they had a page that would display a tweet embedded. And their point was they obviously can't statically build all the tweets at build time. And what it was doing is when you came to the site, it incrementally built the page in response to the request and showed whatever tweet you asked for. And the way it worked was the browser visits a new page that hasn't been visited yet. And the CDN or your edge quickly returns a fallback page with placeholder data, or in this case, you can see these little skeletons right here. And then while that fallback page is being displayed, the page's static build process run just for that page. When the build completes, the fallback page loads the JSON data for that content. Here in this case, we see the tweet on the right. And then future visits get a fully built static HTML page. But it's really important to understand ISG is as much a property of your framework as it is your infrastructure. So if you're going to try and do ISG in your infrastructure, I want you to get a taste for what that looks like. So the request comes in for a particular page. Here it's for product/1. And it's going to hit your edge or your CDN, which is going to check your edge cache. And then it's going to hit your permanent storage here, denoted as Amazon S3. When it gets a miss for both those things, you then have to say, okay, I got to load that fallback page, that loading HTML. And that fallback page could itself also be in your edge cache, or it could be in your S3. And remember, in ISG, different types of pages could have different types of fallback pages. So the fallback page for your category page might have different skeletons on it than the fallback page for your product page. So once you have figured out which version or destination has your fallback page, you can return it back to the user. And at this point, you've really only just served this, the placeholder page with those skeletons. So meanwhile, in the background, you need to have your edge kick off a static site generation process for that single page, or server-side rendering, depending on your implementation, and write that response to your permanent storage and to your edge cache, so it can be served very quickly. And then at this point, you've rendered out the HTML, but you also need the JSON data that powers that page, if you're on, say, Next.js. So again, you need to check your edge cache, check your permanent storage, and then you have to render the data again using server-side generation or server-side rendering. Again, this is for the JSON data. The HTML already done for first load, but you also want it for the JSON data that's used during client-side transitions. And then again, write this back to your permanent storage and your edge cache. And then at this point, you're done. You can display, the loading page actually is going to be fetching this JSON data, and it will get it back, and it can display, the permanent version of the tweet, as you see here on the left. And now subsequent requests for this page will get statically generated HTML and be extremely fast. Now, one thing I've glossed over here is you also need something called stale-while-revalidate that's going to let this update as data in your system expires or data changes. And not every provider actually has full support yet for ISG with stale-while-revalidate, though a lot of folks are working on it. We do support it ourselves. Okay, so some considerations for ISG. It's a feature of your infrastructure and your framework, as you can see here. It requires, you can't just take it and put it on any commodity CDN like you can with classic Jamstack. There's a lot of logic under the hood, and that logic is actually happening at the edge. So a commodity CDN layer may not have that edge logic capability that lets you do that. And it's actually got some level of complexity that you're going to have to implement yourself. Now, again, thankfully, the Jamstack platforms do offer this out of the box. So Netlify has it through Next on Netlify. Vercel has it as the creators of Next, and we support it as well on the MoveWeb XDN. Another key consideration is SEO impact and bot compatibility. If you've got a large site, again, at scale, what you will find is the traffic is not evenly distributed. So a lot of it follows almost like a power law, and you'll have a lot of pages that are infrequently visited, in fact, only being visited by bots and not by users, especially if they're changing frequently. And so the issue, again, it's almost like that client-side rendering. That first load with that placeholder page, it's not quite clear the impact it's going to have on SEO, and even a crawler like Google that can read JavaScript, and less so on a crawler that can't, like a lot of these social media bots. So that area is still new. ISG itself is really new. So we'll see how it works out in the long run. An interesting note on our support for incremental static generation is we've done it in a way that actually can bring incremental static generation support to other platforms. And there's an episode of the JavaScript Jam podcast, it's episode number 1, where our VP of Engineering, Mark Boccato, does a demonstration of incremental static generation support for Nuxt.js. So if you're interested in that, definitely check it out. We look forward to supporting incremental static generation on more frameworks going forward. Another technique you can use is serverless server-side rendering with a CDN or edge in front of it. Again, we're building static or server-side rendered pages on demand in response to traffic, and that's how we're dealing with scale in large numbers of pages. And what you do is you have serverless JavaScript running Node, creating your SSR, and then you make sure you're caching that data appropriately at your edge, whether that's the HTML or, again, the JSON data. And one of the key advantages here is it's a lot easier to bring to a system that has a legacy backend. So I talked previously about being on, say, SAP Commerce Cloud or Magento, and a lot of our customers on those platforms, they want to get to Jamstack. They want to actually have some parts of the site statically built, but it's a lot easier to transition to this model first and then work their way up, and they've had a lot of success doing that. Now, one of the caveats here is there's a lot of kind of debate in the community. Is server-side rendering Jamstack? And you can Google, there are plenty of opinions. I'll tell you my biased opinion. And that's if you take a step back and you look at the benefits of the Jamstack. And these come straight from jamstack.org. Security, scalability, performance, maintainability, portability, and developer experience. To me, all of these actually boil down to 2 things. And that is front-end developer empowerment and serving data from the edge. When you look at scalability, for example, it's scalable because the CDN, the edge, is doing all the work in terms of serving the data. Security, it's more secure because the CDN or your edge is the front door for all the requests, and that's where the security benefits come from. So a lot of the benefits here are really coming from bringing data and serving it from the edge. And so what I would argue is that when you look at it that way, Jamstack isn't binary, it's a spectrum. And anything that has zero DevOps, where there's no servers to manage, so something like serverless, so that's why I say serverless server-side rendering, or where the data is being served from the edge, sits somewhere on that spectrum and legitimately should be considered in that Jamstack spectrum. The caveats, though, are you need to have something that has no DevOps, and you need to have proper cache management. So when you take this viewpoint, it opens up a whole new spectrum of Jamstack-like architectures. So here's an example we call parallel static rendering. And this is a technique for really high traffic websites that have a lot of number of pages with an unequal distribution of traffic. And what you do is you use that same pipeline of serverless server-side rendering. And you let a site deploy like it normally would in serverless server-side rendering. And immediately after the deploy, you start analyzing the traffic logs for the most trafficked pages, or the ones most likely to have a cache miss. And immediately after the deploy, you have a preloader run and pull those in and statically build those pages into the edge. And so unlike classic Jamstack, where you have this build time and then you deploy, this actually reverses it. You deploy and then actually build after the deploy. If a request comes in for a page that isn't part of that high traffic list, that's fine. It'll block, it'll give the user that page eventually. And for most of your high traffic pages, or most of your users they'll get cache hits in the next few minutes after the deploy. So here's an example of this in our platform. The deploy has already happened, and it's going, and if you hit the page, at any point during this site, during any part of this process, regardless of what page you hit, you'll get a result. But if you hit any of the high traffic pages, you're going to get an immediate cache hit. It'll be as fast as Jamstack And it really unlocks in a large site the ability to move faster and not have to wait for build times. So the last thing I want to leave you with is it's not an either or choice. You probably want to actually declare some of your pages static, the ones that don't change frequently, and some other pages dynamic. You might even take a page and make some parts of it static and some parts of it dynamic. So the recommendation if you're operating at scale is to choose a framework and platform provider that lets you flexibly mix those techniques as needed. So I want to switch gears and talk about A/B testing and performance. So let's talk about A/B testing. A/B testing is one of those things that's really easy to ignore when you're working on a smaller site or you're working on a personal site or blog. But then when you're operating at scale, it's almost completely essential because almost everything in a large site that's making money, you need to demonstrate a return on investment for those changes. And to illustrate that, if you look at the percentage of websites using A/B testing, in the top 1,000,000 sites, it's only about 1 out of 10 sites are using A/B testing. As you go up to the more scaled sites, top 100,000 sites, it's 1 out of 4. And when you're dealing with the top 10,000 sites, it's half. It's 50%. 1 out of 2 sites are doing A/B testing. And so it's one of the biggest problems you won't think about unless you're operating at this scale. And it's one of the biggest open problems in the Jamstack space. And just recently, earlier this month, the Web Performance Working Group had a really great deep dive session on performant A/B testing. I highly recommend you go listen to it if you want to know more about this in detail. Here actually is Tim giving a great talk that works through a couple of various scenarios he's seen using client-side A/B testing on websites. In this one, I don't know if you can see this in the image, but basically the page is hidden for 2 seconds. The content is there, but the page is hidden because the A/B testing tool is running in JavaScript client-side and needs to block the rendering of the page and to avoid flash of the original content. And these are classic in client-side A/B testing, which traditionally has been kind of the only tool you can use in a static Jamstack site. But it results in poor performance. So poor it might actually nullify your test. So the ideal answer here, again, is bring sophistication to the edge. Have the A/B test traffic split occur at your edge or your CDN. And both Netlify and MoveWeb currently support this with a point-and-click interface. In our case, you can actually specify various headers, and you can create complex rules to do that traffic splitting. And again, this is not about totally replacing your A/B test system. You can still use Optimizely. You can still use Google Analytics to analyze the data. All that we're really recommending is use the edge to split your traffic so that you don't actually set back all the important caching and Jamstack work you've done. Another related area is personalization. And a lot of people think about personalization, they think about each page being unique to that person. But the really more common case is segmentation for a lot of sites at scale. And this could be based on language or geography. So we had a customer, for example, who has customers in Canada and customers in the United States. And the prices are different because one's in Canadian dollars and one's in US dollars. And so the server-side rendered versions of those pages need to be different. The general guideline we have here is if this content is below the fold and it's really personalized to a cohort of 1, then see if you can client-side render it and late load it. If it's above the fold personalization, then you really need to add that personalization or segmentation to your cache key so that whatever user is coming from, say, different geographies, they still get great performance, but they get something tailored to their segment. I have an example here for how we do it in the MoveWeb XDN platform. It makes it really easy to segment your cache key based on, say, currency or geography, but you can do this on other platforms as well. Okay, lastly, I want to talk about performance. It's a really important area, and with Jamstack, performance isn't a given. It isn't automatic, despite it being one of the key pillars of the Jamstack. There's a great blog post from Nicholas Hoisey called "Jamstack is fast only if you make it so." And we've talked a lot about making sites really fast by bringing data or serving data from the edge. But once that data gets there, if it's loaded down with JavaScript, it's going to slow your site down. And that's what Nicholas is talking about here. He says too many Jamstack sites are very slow. And the issue is they're loading a lot of JavaScript. And this is going to get really more and more important, again, at scale. If you're on your personal site or blog or maybe a smaller site, organic traffic from search engines isn't that important. But if you're, say, the typical e-commerce site, about 50% of your traffic comes from search engines. So how you get ranked by them is critically important to your bottom line. And now in May 2021, just a few months from now, site speed is going to be a concrete ranking factor for your page. And time is running out because May is only a few months away, and only 1 out of 4 sites on the internet passes Core Web Vitals. And in e-commerce, it's even worse. It's closer to 1 in 10 sites pass Core Web Vitals. And optimizing Core Web Vitals takes longer than you think. It's not like Lighthouse. Lighthouse is an on-demand measurement simulated, effectively in a lab, and you can throw 1,000 ideas at it in a week and know whether you're improving your Lighthouse score or not. Core Web Vitals is different. Core Web Vitals is measured from real user traffic. So you do not know if you have improved your Core Web Vitals till you've put it live and let it wait for a few days to a few weeks to find out if you've improved Core Web Vitals up or put it down. Also, the data is aggregated in Google Search Consoles in ways that for sites at scale, it's hard to isolate which pages are causing problems. And finally, Core Web Vitals can have a lot more confounding factors. You could have 2 identical pages built the same way, the same technology, the same content. But if the traffic is different, say one is serving one country and one is serving another country, or the pages visited are different, you could have confounding factors changing the Core Web Vitals for those 2 pages. And so the bottom line here is that Core Web Vitals takes longer and is more difficult than Lighthouse to optimize. And your Core Web Vitals score is not necessarily equal to your Lighthouse score. Here we have a chart on the right. I took the IR 500, that's the Internet Retailer 500. Those are the largest e-commerce sites in the US, and examined one of their Core Web Vitals scores, first input delay, FID, and looked at their Lighthouse score in PageSpeed Insights for its analog called time to interactive, or TTI. And what you can see is, yes, those values are broadly correlated in aggregate, but there are plenty of outliers. So specific values on your Lighthouse score don't necessarily mean you're going to get a great Core Web Vitals score. Again, could be because of your traffic, even though you built a relatively fast page. So I like to say that optimizing Core Web Vitals is a lot like an A/B test. You don't know whether you've actually made it work until you put it live and you have to wait a while. And so if you're really trying to triangulate at scale how to improve your Core Web Vitals, I highly recommend using real user monitoring, or RUM, where your traffic is measured from real traffic, the same way Core Web Vitals and Google are measuring traffic. And in that light, I'm really happy to announce that RUM is going to be coming to the MoveWeb platform. It'll be in beta soon. If you're interested in being part of the beta and kicking the tires, we'd love to have you. Feel free to reach out to me. And then finally, if you want a steady stream of Core Web Vitals news, we've launched a newsletter at corewebvitals.email. Sign up for that if you want to hear more about Core Web Vitals as we march to the 2021 release date and beyond. And with that, thank you. I look forward to answering all your questions in the JS World Q&A right after this session, and I hope you have a good conference.